All right, ready to go on the Pythagorean identities. Just trying to remember how we have done that in the past. Okay, Pythagorean identities. Now, I want you to think about the Pythagorean theorem, right? This is a squared plus b squared equals c squared. But I also want you to think about the unit circle, okay? So let's think about the unit circle, all right? Let's just draw a little piece, right? The unit circle, right? All your, radii are 1, okay? And we've got a right triangle here. And then we have x here, and then we have y here. But we now know y to be equal to sine of theta, and we know x to be equal to cosine of theta. Okay? And that is why we have this right here, right? Where x squared plus y squared is equal to 1 squared. Right? So technically this is like 1 squared. Okay? But 1 squared is 1. Okay, so that's where this comes from. All right? So this is like the original Pythagorean identity. The rest of this comes from other, like, manipulating and stuff of sine, cosine, tangent. So we've got sine squared plus cosine squared equals 1. Okay, well, we're actually going to now isolate a few different things. Let's isolate sine squared. Okay, so we're getting sine squared of theta by itself. Well, that means that we've got 1 minus cosine squared of theta. That's a Pythagorean identity. So this is a Pythagorean identity. This is a Pythagorean identity. Okay, because we isolated sine squared. Let's isolate cosine squared. Okay, getting that by itself. Right, cosine squared. Well, we're getting rid of sine squared over here. So this is 1 minus sine squared of theta. Okay, that's a Pythagorean identity. So you could replace cosine squared of theta with 1 minus sine squared of theta. Okay. Another way to do it is you could have the negatives. Okay. So you could essentially multiply negative 1 times this entire thing. And so that would be the Pythagorean identity where you have negative sine squared, okay, is equal to cosine squared, right? It was negative, now it's positive, and then minus 1. Okay, that's another Pythagorean identity. Okay, you could have another one where you're multiplying this by negative 1. So another Pythagorean identity is negative cosine squared theta, okay, equals, well, we're multiplying negative 1 to here, so now this is sine squared of theta, and then minus 1. Okay, these other ones I'm going to kind of rattle off pretty quick, but just some background. This, 1 plus tangent squared is equal to secant squared of theta. It comes from this, okay, but it's as if you were to divide the entire thing by sine squared of theta. I'll let you think about that, okay, but that is one Pythagorean identity. You could also isolate the 1, so we're going to end up with secant squared of theta minus tangent squared of theta. Right, we're getting the 1 by itself. And then you could get tangent by itself, where we've got tangent squared of theta is equal to secant squared of theta minus 1. Similar process here. I'll tell you now, this is a Pythagorean identity. These are all Pythagorean identities. These are just things that we know to be true, equivalences that we know to be true. Gosh. That all stem from this right here. Okay. The last little tree, the last little family, is if we were to take this original and then divide throughout by cosine of theta. I think I got them backwards. This original is as if you were to divide yeah, this is the one with, I'm going to pause it real quick. I'm going to get this straight in my brain. Yeah, okay. This one is actually where you divide throughout by cosine, okay? So you have this original. If you were to divide this entire thing by cosine of theta, you're going to get this. If you were to divide this entire thing by sine of theta, you're going to get this, okay? So that's actually what that comes from. All right, so same thing here. You can isolate the 1. So you can get 1 is equal to secant of theta. Nope. cosecant of theta minus cotangent of theta. And then you're going to get the cotangent by itself too. So you got cotangent of theta is equal to cosecant of theta minus 1. Those are the Pythagorean identities. Okay, you can use these, but those are all certain things where it at times helps to change what we have in the problem and to manipulate and go back and forth between them, depending on the trig identity you're trying to solve or different things like that. And we'll get, for now, let me just say in finality, these are all properties that we can use. We will see how we use them another time. Right? That is for another lesson. You guys take care. See you later. Bye.